Hey guys, so this is an add-on examples video to my lesson video on graphing polynomials. So I'm just going to graph these three polynomials. These are a little different from what I was doing previously. So let's just jump right into it. Okay, so we want to just graph this polynomial, and this is all the information that we have. And so you kind of have to just think first about like, how are you going to get the zeros? Now, sometimes you're able to like factor something like this easily, but in this case, we really can't factor this very easily. So we're going to have to figure out the zeros with another method. Namely, I'm going to use the rational zeros theorem, where I allow the last term to be the factors of my p, and the leading coefficient are the factors of my q. So for my p, I just want to think of what are all my factors of 8. So that would be 4, 2, and 1. And then what are all the factors of my leading coefficient? Well, there's 1. That's it. So what the rational zeros theorem says is that I take p over q. So these over this. So it's actually just, these are the list of possible rational zeros that could work for this polynomial. Okay, so yeah, now we have to just figure out which one of these is a zero. And you know, I've talked about this in other videos, so this is kind of a guessing game. I don't know, let's try 1. Let's see, I'll put a little space here. Okay, so I've got 1. I'm going to use synthetic division here, which is what I've been doing in this whole series. So I bring the 1 down. 1 times 1 is 1. 1 plus 5 is 6. 1 times 6 is 6. This becomes 8. This becomes 8, 0. All right. Yeah, found a 0. Okay, totally by luck. So I got lucky. So let's see. That means that if 1 is a 0, then a factor of this polynomial is x minus 1. So it always goes in opposites, right? And then the resulting polynomial that I'm left with is, so this started with x cubed, so this starts at x squared. So this will be x squared plus 6x plus 8. All right, so let me make some space. All right, so now that I have this quadratic, so this just so happens to factor. Cool. So this factors as x plus 2, x plus 4. So, you know, the goal here was not to factor, but sometimes if you can factor, then it makes finding your zeros much easier. So my zeros are 1, -2, and -4, which means what I really need to find are my x-intercepts. So all these things are related, right? So my x-intercepts are 1, 0, -2, 0, and -4, 0. Oops, -4, 0. All right, so, okay, that was kind of a big thing. Next, we have to find the y-intercept. So let me just get rid of the p and q on here. So what I want to do now for my y-intercept is I want to plug 0 into the function. And I can tell just from plugging 0 into the function, this is 0, 0, 0, and -8. So f of 0 is going to equal -8. So this is the point 0, -8. All right, cool. So now I just really need to know a few other things to get this party started. So the number of turning points that I'm going to have, I have a turning point in between each x-intercept. So I have a turning point here and here. So I have 2 turning points. And then the end behavior, since this is x cubed, this is going to act like the function of x cubed. So my end behavior then is going to go this way. All right, so we've got everything we need. So let's summarize it and make some space. Okay, so I've summarized everything. I've got a graph. We're going to go ahead and graph this. So what I like to do first is I like to just plot all my points. So I have 1, 0, -2, 0, -4, 0, and then 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've plotted all my points. So my end behavior now, I know that I need to start, since my end behavior goes this way, I'm going to start this way, and then I'm just going to start making my turning points. So I'm going to go here, turn, here, make sure I go through the y-intercept, I'll turn here, and now I'm just going to keep going, right, to honor my end behavior. All right, now that might not be exactly the graph, but it's a good approximation of just how it turns and the shapes and all that. So we will call that good enough. And so we're good to go on this one. Okay, so moving on to B here. So for this one, I guess the first thing that I notice is that there is, there's a GCF. Words. Okay, so if I factor out x squared, what am I left with? 3x squared plus 5x minus 2. And that's cool because that reduces us to a quadratic. And so then it's like, ooh, can I factor? Maybe. I don't know. So let's see if we can factor. So I'm going to play around with this for a second. So let's see, I have 3x and x. So let's see, if I add 2 here and subtract 1 here, this will give me 3x times 2, which is 6x, and then minus 1x, which is 5x. So yes, it does factor. So that's cool. So then I can just set each one of these factors equal to 0. So the thing you don't want to forget here is that you have this x squared. So that actually just is a 0. If you set x equal to 0, that is 0. Like, don't, like, it like messes with people's heads because it's like the simplest one. There's nothing to solve for. It's just 0. That's it. That's what it means. Okay, if I set this linear factor equal to 0, so if you're unsure, you can always just set it equal to 0 and solve for it. And so I'd get 1/3 is a 0, and then -2 is my last 0. And again, I just set each factor equal to 0. Okay, so get rid of all that. And all right, so now I've got my zeros, which means that I can now come up with my x-intercepts. So that's 0, 0, 1/3, 0, and -2, 0. Next, I want to come up with my y-intercepts. So I'm going to go ahead and plug 0 into my function, which if I plug 0 into this function, it's just going to give me 0. So the y-intercept and the x-intercept are the same thing, which can happen. And then, so the number of turning points that I'm going to have. Okay, so I have 1, 2. So I have 2 different turning points in between my x-intercepts. So I have 2 turning points. Now, one thing that you want to keep in mind, this has a multiplicity of 2, which means that we need like a parabola type shape at it. Okay, so it will end up making another turn effectively. And then my end behavior, well, this is dominated by 3x to the 4th, so that's going to behave like this, right? Okay, so let's summarize all that information and make some space. Okay, so I've got all my information laid out now. So, you know, first I want to just plot my points. So there's 0, 0, 1/3 0. You just got to approximate it. That's not going to be fun, but, you know, we'll just deal with it. And then -2, 0. Actually, let me redo my axes. All right, so my scale's a little crazy, but at least now I can plot 1/3 a little bit easier. And then, let's see, -2, 0 right here. Okay, so I've got my kind of weird axes. All right, so at 0, I need to make sure that I have a parabola shape, so I'm just going to note that there. My end behavior goes like this. So I need to start here and go through my x-intercept, and then I'm going to turn. Now when I get to 0, 0, remember you need to reflect a parabola shape. So just in the direction that this polynomial happens to be going, this will end up becoming an upside down parabola. So you kind of have to rely on like the direction that everything's going and then make it make sense. Okay, and then I turn one more time and go this way. Okay, so I probably have the turns right. Again, if you were to look at this like on Desmos.com, you were trying to just compare the graph. I might not have the peaks totally right, but the idea here is to at least just get like a good sketch, like the general idea of it. Okay, so we have one more here. So this one is already factored for us, which is cool, but now we just have to figure out what is the degree of this polynomial. So the degree of this polynomial, I just add the multiplicities, so that's 5. Okay, so the good news is that I can really easily find my x-intercepts because I can just really easily see the zeros here. So my x-intercepts are going to be 1, 0 and -2, 0. Now for my y-intercept, this might be just a little bit more work because of how this is written. So if I plug in 0, this becomes -1 cubed times 2 squared. So if I work that out, Let's see, that's going to give me -4. So my y-intercept is 0, -4. Okay, so I've got my intercepts. I got my I got my intercepts. Next, the number of turning points that I'm going to have. So I'm really just going to have like one turning point in between these two intercepts. So 2 turning points. And then finally, my end behavior. So since this is a degree 5 polynomial and there's no negative in front, my end behavior will look like that. Okay, so let's summarize all this and graph it. Okay, so the thing with this one is we want to make sure we're paying attention to the multiplicity. So, okay, if I graph all these, once again, let me just set a different axes. Okay, that's much better. Okay, so now I've got 1, 0, -2, 0, and we also had, oh wait, -4, 0, -4. I forgot to write that one down. 0, -4. Okay, so my end behavior looks like this. So I'm going to start down here, but when I get to -2, I need to have a parabola shape, right? So I'm going to go up this way, parabola shape, okay? Now, I'm going to have a turning point somewhere in here. And now, when I get to this point, I need to have I need to reflect the multiplicity of 3. So what I want to have is I want to make sure that I have kind of like that x cubed shape at that 0. So x cubed shape, boom. And now I have reflected the proper end behavior. I've got my one turning point while also reflecting what's going on with the multiplicities. So that is how all of that works. Okay, and so that brings us to the end of this video. If that was helpful, please consider leaving a like for it. And otherwise, I will see you guys in the next video. Bye-bye.